Okay, in this video we're going to take a look at vector journeys. Okay, when thinking about vectors, the start and end points are not always relevant. Okay, as long as we have vectors that are parallel and have the same magnitudes, then we consider those vectors to be equal. Okay, so if you were to hold out a pen in front of you with the pen pointing to the right, think of the size of that pen and it's pointing to the right. As long as you keep that pen pointing to the right out in front of you, you can then move it all about. It'll still be the same vector because it's always pointing to the right. The size of the pen doesn't change, but where you place it is always going to be equal to where it started. Okay? So a vector journey, when we do this, all we're doing is looking for alternate vector paths. Okay? Vectors that are equal to each other. So example 11 here, it says the vector UVWXYZ is a regular hexagon, with vector UV is vector A, vector XW is vector B, and vector YZ is vector C. Find in terms of A, B, and C, vector YX. Okay, so the vector YX is here, going from Y to X. Looking along that diagram, what other vector is going in that direction? It would have to be vector A. So the vector Yx is the same as vector A because it's going along in the exact same direction. Next one, the vector xv. So if I want to get from vector x to vector v, then I'm going to travel along vector x to here. Then I'm going to travel along this vector here to get to v. So to get from x to v, I go along vector b, but I'm also going along vector c because that's parallel to the vector on the bottom. So I can say that a shorter way of doing the vector x to w to v is just to do the vector xv. So xv is going to have components b plus c. Okay? yw is the same as travelling along from y to x and then from x to w. So that's going to be vector A and that's going to be vector V. So I can say that YW is the same as saying A plus B. The final one, vector ZX. Well, if I go from Z to X using the vectors I know about, that's the same as going against the grain of vector C and then along this one here, which is the same as vector A. So I can say it's going to be negative C plus A, which is just A minus C. Okay? Let's look at example 12. In the diagram opposite, OABCD is a regular hexagon again, with centre M. Vectors A and B are represented by OA and OB respectively. Express AB and OC in terms of A and B. Okay? So, if I was to look at the vector AB, the vector AB is located here, going from A to B. The vector OC is going from here to here. Okay? So I can say that the vector AB, I should say, an alternate way is to go against the grain of vector A and then along vector B. So I can say that the vector AB is going to be the vector negative A plus vector B, which is just B minus A. Okay? For vector OC, I can say that for vector OC, look at what we already know about it. Well, I can, if I look at this vector here, which is vector AB, that's the exact same journey as going from O to M. So I can say that vector OC is the same as doing the journey from O to M, and then plus the journey from M to C. So that's going to be the journey of AB, which is B minus A, plus another journey of B minus A. So that'll just be 2B minus 2A. And that should make sense, because if this journey here from A to B is just vector B minus A, the journey to go from O to C is just that first journey from A to B, and then repeat that same journey from A to B again. So it's 2 times it, so it's just going to be 2B minus 2A. Okay?